Hello, calculus students. I want to say one thing before we start. In general, make sure you're doing your homework, okay? I understand you may not do every single problem, but make sure you do enough to know you actually get it. I always did all my calculus homework, but that's because I love doing math homework, hence why I'm a math teacher. But please do that. In class, I generally give a warm-up, but it's just as good and just as effective if you do your homework and make sure you're understanding. And again, please email me if you don't understand, email me a picture, whatever, or come to my office hours. I just want to make sure you're doing okay and I don't want you to get lost. Okay, 2.1a notes. Here's where we start to get into the real calculus versus just the lines and slopes. So 2.1a, as a review, slope is m equals average rate of change equals change in y, delta y, over change in x, delta x. So let's say if you drop an object, it's getting kind of like physics here. We can use the equation d equals 16t squared to illustrate this, where d is your distance and t is your time. Okay, so let's say we have a time column and a distance column. T is our input, d is our output, or independent dependent variable if you prefer. We have the point 0, 0. At 1 second, the distance is 16, 2, 64, 3, 144. Let's say the time is in seconds and the distance is in feet. Okay, so now let's talk about speed. So keep in mind, speed is equal to distance divided by time. So if we want to find the average, AVG average, it's not a U, sorry, I can make a little curly Q. My V's tend to be a little too curvy. If we want to find the average speed between 0 and 2 seconds, remember an average is our slope, so we can do change in y over change in x, and just keep in mind our change in y is really like our change in distance, and our change in x is really our change in time, but x and y are kind of our general variables, okay, with slope. So change in y over change in x, 0 to 2, well, we have our points 0, 0, and 2, 64, so our change in y is 64 minus 0. Change in x is 2 minus 0, 64 divided by 2, which is 32 feet per second. So that's our average speed. Now let's find our average speed between 1 and 2 seconds. So 1 second to 2 seconds. So now our points are 116 and 264. Change in y over change in x will be 64 minus 16 over 1 minus 0. 48 over 1, which is 48 feet per second. And the idea is here that we're getting closer and closer. So 0 to 2 is a 2-second spread. 1 to 2 is a 1-second spread. So now, can we get even closer to 2 seconds? Keep in mind this lecture always makes it sound sort of like a negative thing, but most of this lesson is not something you would have to recreate. I'm just showing you something that we'll get to at the end. Okay, so this part is not something you would have to recreate, or the AP test would ask you, or show me why this is true. This is just kind of a demonstration. So again, can we get even closer to 2 seconds? So time and distance can try 1.5 seconds, 1.9 seconds, 1.99 seconds, 1.999 seconds. So again, d is 16t squared. So if t is 1.5, this would be 16 times 1.5 squared, which is 36. Didn't do it in my head, I already had it written down. You could figure it out on paper, you could use your calculator, doesn't matter at this point. For 1.9, 16 times 1.9 squared, which is 57.76. 16 times 1.99 squared, 63.362. 16 times 1.999 squared, which is 63.936. Okay, I'll tell you this approximately 1,000,000 times this year, but for AP, round to 3 decimal places. My instinct tends to be to round to, 2, but AP, 3, always 3, or more, but I usually just stick with 3. So now the average from 1.5 to 2 seconds. So then our points, we have 1.536, and we have 264 using this point and then the table up above. So then our change in y over change in x, or average speed, is going to be 64 minus 36 over 2 minus 1.5, which is 28 divided by 0.5, which is 28 times 2, which is 56 feet per second. And we could do 1.9, but I'm just going to skip right to 1.99, just in the interest of time, and kind of get the point at the end, hopefully. So average from 1.99 to 2 seconds. So now our points are 1.99, 63.362, and 264. So we're getting closer and closer to 2 seconds. Now, our delta y over delta x is 64 minus 63.362 divided by 2 minus 1.99. And honestly, this is all a calculator. You're welcome to try to do it on paper or whatever, but I would use my calculator for this. 63.8 feet per second. So the idea is here, sorry, lost my train of thought for a second. Just, like in a real class, that happens. Okay, so now basically what we're doing, we were trying to get closer and closer to 2 seconds. So we went between 0 and 2, 1 to 2, 1.5 to 2, 1.99 to 2. And it looks like the average rates of change are increasing, 32, 48, 56, 63.8. So now we're going to talk about the idea of instantaneous. Lots of syllables. Feels a little bit like a fake word. Instantaneous speed, or rate of change. And this means like right now. Like right now, what's the speed? Right at this second. If you're driving, right at this second, what does the speedometer say? How fast are you going? Okay, so right now, this occurs when the denominator of change in y over change in x is 0. Okay, so when the denominator is 0, basically when change in x equals 0, there's no difference between the two times. So we went from 0 to 2, 1 to 2, 1.5 to 2, 1.99 to 2. So this had a 0.01 or 1/100th of a second difference right up here. But now we're going to say, what if there's no difference at all and our delta x, or our denominator, was 0? We kind of have to mess around with the math a little bit when we do this because you can't really divide by 0. Kind of breaks math. So using d equals 16t squared, we're going to find the average, AVG average, speed, or rate of change between 2 seconds and 2 plus h seconds. The idea is that we want h to go to 0, so that we're looking at the difference between 2 seconds and 2 plus 0 seconds. Okay? And again, distance is speed speed is distance over time. So now between 2 seconds and 2 plus h seconds are 2 points that we have, because remember this is really just slope, are 2 comma f of 2 and 2 plus h. So our time was 2, and now our time is 2 plus h comma f of 2 plus h. So now it's just slope, change in y over change in x. So our y2 minus our y1, so we have f of 2 plus h minus f of 2 over 2 plus h minus 2. Okay. This pretty quickly simplifies. It's the bottom. So f of 2 plus h minus f of 2 divided by here, 2 plus h minus 2, we just have h. And so our goal is for h to be 0, right? But if we put in 0 right now for h, we'll have f of 2 minus f of 2, which is 0, divided by 0. So we have to do more math. So if we evaluate d equals 16t squared at 2 plus h, so f of 2 plus h is really 16 times 2 plus h squared minus 16 times 2 squared. Again, we're just plugging in to this equation. We're plugging in 2 plus h and then 2 divided by h. 16 times, well, 2 plus h squared is 4 plus 4h plus h squared. If you need to do that, kind of multiply that out over on the side, that's fine. Minus 16 times 4, all divided by h. So now we have 16 times 4, which is 64, plus 64h, plus 16h squared, minus 64, all over h. Getting there. So now let's see, the 64s will cancel. So we have 64h plus 16h squared divided by h. Now we can get rid of the h on the bottom. And then we don't have to divide by 0. Then we don't have to divide by 0 anymore. Sorry, I got very excited. So those h's cancel. This will turn into just a regular h. So we end up with 64 plus 16h. And remember, our plan was for h to be 0. So as h approaches 0, or there's no difference between the two times, like 2 and 2 plus h are the same, our instantaneous speed is 64 feet per second.